Alright, so our first problem dealt with the function f of x is x cubed plus x. And we were looking at this function on the interval from 1 to 7. And, first task was finding the average rate of change as x varies from 1 to 7. So, if you think about what I'm asking you to do here, when x is 1, 1 into f of x produces 2. When x is 7, 7 into f of x is like 350. Average rate of change just says every time x goes up by 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 7. What do we want to add to the x values every time as we move along? Like how much do we have to add, or how much do we have to subtract? In this case, we're going to add, like on average, is there one number I could add every time? So, the answer is, I'll show you why, but it ends up being 58. Well, if you add 58 to 2, you get 60. And then if you add 58 to 60, you get 118. And if you add 58 to 118, you get 176. And if you add 58 to 176, you get 234. And if you add 58 to 234, you get 292. And then if you add 58 to 292, you get 350. So average rate of change just says, hey, if I added or subtracted the same amount every time, x increased by 1, what would that amount be? So that, if I started at 2 and I wanted to end it at 350. And so really the computation just ends up going, well, I know I'm going to end at 350, and I know I started at 2, so that's a difference of 348. And I started with an x of 1 and ended with an x of 7. So 7 minus 1 is 6. So in 6 increases, I want to cover this gap of 348. Well, if you divide 348 by 6, it'll tell you what you need to add every time. 348 over 6 is 58. Okay. So, and really, computationally, if you were looking for a formula here, average value on f of x from a to b, you'd be looking at f of b minus f of a. Those are your y values over b minus a. And we got 58. Okay, so the average rate of change for our function is 58. Now, 58 is the slope of a line. It's actually the slope of the line that connects these two ordered pairs. That connects the ordered pair 1, 2, and the ordered pair 7, 3, 50. So if we looked on a graph, I gotta adjust the window here. So we want to go all the way up to 350. Okay. So I need to copy this graph. Alright, so let's get a picture of this graph so I can use it. I can show you this. There's the program. So, clipboard, okay. So here's your graph. Okay, so I'm going to locate the point 1, 2, over 1 up to, that's like over 1 up to, that is here. And then if I locate the point 7, 350, 7, 350 is right here. Now if you connect these 2 points with the line, that secant line, the slope, that's our the slope of that line is our average rate of change. Slope is 58. And the slope of that line represents our average rate of change. Now the next part where I say, tell me when you achieve that slope of 58. What I'm asking you to do computationally is set your derivative equal to 58. But if you look at the picture, I'm saying where along your curve, is it right here, will you have a tangent slope of 58? Well, it's obviously not there. I mean, you can see with that orange line that slope doesn't match the red one. So I can kind of start by guessing where along my curve do I think I'll have a tangent slope of 58. Well, I mean, it's not up here, right? That line's a lot steeper. So just eyeballing it, I don't know, it looks like it would be somewhere in here maybe, where my tangent slope, and maybe a little bit further than that. So yeah, further to the right as far as x values go. So I don't know, I'm thinking 4 range, somewhere around 4. Okay, well, to compute that, if you want to know when is the slope of my tangent line equal to 58, well, you got to find your derivative, and just remember f of x is x cubed plus x. And your derivative, just the power rule, is 3x squared plus 1. So we want to know when does 3x squared plus 1 equal 58. Now, let's just go to Wolfram. I mean, that's not that interesting of a problem to solve. It's just a computation. So I jump to Wolfram alpha, and I'm just going to say, hey, Wolfram, solve this equation, 3x squared plus 1 equals 58. And you could use your TI-89 as well. So 3, I suppose I have to tell it to solve me this. 3x to the second equals 58. Whoops, 3x to the second. And obviously my PC's kind of freaking out here. Let's try this again. 3x to the second equals 58. Solve that for x. So tell me when that happens. Oh, and I'm sorry, I had 3x squared plus 1. 3x squared plus 1 equals 58. So plus or minus 4.359. Okay. Well, when I say plus or minus, you don't care about both of them, because we're only looking from x equals 1 to x equals 7. So at about 4.359, we achieve that average rate of change, 4.359. So I would just make a note, f prime of x equals 58 when x is approximately 4.359. So we've done average rate of change, and then when do I achieve that average rate of change? And we got 2 more. We've got average value, and then when do I achieve that average value? So I'm going to use that graph again for average value. Okay, so there's a picture of my graph. So you think about all of the y values that exist from x equals 1 to x equals 7. From x equals 1 to x equals 7. The weird thing is you have infinitely many y values along this curve. We've got a process that's going to get us to finding the average y value. Okay. So symbolically, if you wanted to calculate that average y value from 1 to 7, you'd take this area and divide it by this distance. Well, 7 minus 1, that's 6. So I need that area divided by 6. Well, we know about area. We know that an integral can calculate it. So I'm just going to go back to Wolfram, and I'm going to find that area, and we'll bring that answer back and divide it by 6, and we'll have our average value. So that shaded area, symbolically, that's the integral from 1 to 7 of x cubed plus x dx. So I'm going to take that to Wolfram. So we're back here. And let's get an answer. So instead of solve, I'll have integrate. Integrate x cubed plus x as x varies from 1 to 7. 624. Okay, so we'll take that answer back. That's our area, 624. So that guy is 624. So average value of x cubed plus x on 1 to 7 equals 624 divided by 6. Okay, and 624 over 6 is 104. That's the average y value. The last part says, hey, when does my function achieve that average y value? And graphically, if you think about where 104 is, 104 is right here. You think about what does that mean for the picture. Okay, so my average y value right there well, we'll talk more later, but if you took this rectangle here, this blue rectangle, it would have the same area as all of this stuff. But our last task is to say, hey, where does our function achieve that average value? So you're just going to go back to Wolfram and you're going to say, hey, solve this for me. When does my function x cubed plus x, when does that thing equal 104? And you're going to say comma x. So we'll go back, we'll get that answer, and then we'll be done. Okay. So you say Wolfram solve, when does x to the third plus x equal 104? Uh, 4.632. So average value of x cubed plus x from 1 to 7 is achieved when x is approximately 4.632. Okay, so you got, there were 4 things I asked you for. When does it happen? Where is it? So there's your average value and when it happens. We had, what's the average rate of change? 58, and when does it happen? Right here. And notice, it doesn't achieve the average rate of change where it achieves its average value at 4.632 and 4.359. So thanks for watching. Hopefully it helped, and you got 4 more problems to do, but I'm going to end this video now.